The Hubble and the Webb telescopes have a lot in common. Both work in the vacuum of space, have mirrors that collect light from distant stars, use radio signals to transmit images, and get power from the sun. Unlike the Hubble, the Webb is an infrared telescope, says project scientist Matt Greenhouse.
It will allow the Webb to see these very primordial objects, these objects that are among the oldest objects in the universe.
And to do that, the Webb will be sent 1.5 million kilometers above Earth's atmosphere. Unlike Hubble, which flies in low Earth orbit and sees only visible, ultraviolet, and a small segment of the infrared spectrum.
With infrared radiation, we can peer through clouds of dust in space that obscure regions where stars are being born around us today. With spectroscopy, which is spreading light out into its component colors and observing them one at a time, we can see features of individual atoms and molecules in space that will allow us to understand the chemistry that occurs in space.
Webb's ultralight mirror is also 6 times bigger than Hubble's, and its instruments must be kept extremely cold.
More than minus 200 degrees centigrade cold, which is what we call a cryogenic temperature. The reason for that is that anything above absolute zero emits infrared light. So if we had infrared glasses on right now, we would see our bodies glowing in the infrared, the walls and ceiling of the room would be glowing in the infrared. And if we didn't cool the telescope, it would be blinded by its own infrared emission.
The Webb's multi-layer sun shield helps keep light from the sun and reflected light from the Earth and Moon from heating up the telescope and blocking astronomical signals. All this cutting-edge technology combines to make the Webb 100 times more powerful than Hubble.
We have a special capability in this instrument payload to observe as many as 100 galaxies at a time and obtain their spectra simultaneously.
With 3 years to launch, the Webb is now in its assembly and testing phase. Greenhouse says the team must avoid the mistake that sent Hubble into space with a flawed mirror.
One of the big things that we learned from the Hubble is the Hubble didn't do something called an end-to-end optical test, where we take the entire observatory and shine light through it the way it will be done in space and make sure everything works.
Unlike the Hubble, the Webb cannot be repaired in space, so the team has only one chance to get it right.
And like Hubble, it's likely that after this mission is over, we'll look back and find that the most important discoveries and the most important questions that were answered are not the questions that we had in mind when we designed and built it.
The Hubble has operated much longer than expected, and Greenhouse hopes the Webb will too. The James Webb Space Telescope is a project of the U.S., European, and Canadian space agencies. Rosanne, Skirble, VOA News, Washington.